Hello, welcome back. In last video, I explained about the key features of the hypervisors and at the architecture level. So in this video, I'm going to explain about the virtualization features supported by the ARM architecture. The key feature of the hypervisor can be implemented using the virtualization features in case of ARM architecture. And then the key operation is that the controller is passed to the exception level 2 when the exception occurs at exception level 1 or exception level 0. So that kind of operation is called the exception model from the perspective of ARM architecture. So let's take a look at how the exception is taken to the exception level 2. So let's assume that the exception occurs at exception level 1. Let's know that Linux kernel or real-time operating system can be running at exception level 1. In general, if exception occurs at exception level 1, then the exception handler at exception level 1 will handle that exception. Those kind of scenario is implemented when there is only one operating system in your target board system. But if you configure hypervisor control registers in the ARM architecture, then control is transferred to the exception level 2 instead of exception level 1. So let's take a look at these operations step by step in more detail. As a first step, a software is running the particular assembly instruction. Let's suppose that the exception occurs because then ARM core cannot execute specific assembly instruction. And in this case, then controller is taken to the exception level 2 instead of exception level 1. Those kind of operation is important whenever you think about features of hypervisor. In particular case, controller is transferred to exception level 3 instead of exception level 2 or exception level 1. So if you configure some of the register called secure configuration registers in ARM architecture, then those kind of control flow can be identified. So number of the features that is implemented in the hypervisors can be only possible with this exception model. Then let's take a look at another diagram about this operation. Let's assume that exception occurs when the software is running at exception level 1. So as this step, then and some of the situations include the access to invalid address, or sometimes core cannot decode the specific assembly instruction in this case. In normal situation, control is transferred to the exception vector table at exception level 1, but in this case, the control is taken to the exception level 2 instead of exception level 1 by branching into the exception vector address that is specified here. This address can be calculated using this equation, adding offset JRX 400 to exception vector base address that is stored inside VVAR-ER2 register. So what I mean is that if the crash occurs at the exception level 1 or the particular assembly instruction is executed, and in this case, control is passed to the exception level 2. what is going to happen after overload occurred at exception level 1 in this case? If exception is identified at exception level 1 due to critical error, in this case, exception handler at hypervisor is only terminate or reset the particular guest OS, not to reset the whole system, because then hypervisor does not have to reset the whole system because there is a problem from the perspective at exception level 1 when the guest OS is running. What I mean is that hypervisor does not have to reset guest OS too. Those kind of scenario can be implemented with the hand of the system software engineer of the specific company. Then now that we explore the exception model related to synchronous exception, let's take a look at another control flow when the IRQ exception occurs. Let's know that IRQ exception can be generated when the external event occurs. The typical example of external event is the situation where the peripheral device signal interrupt. Then right after interrupt is signal from the peripheral device, the hardware that identify that the interrupt is signaled from the peripheral device is interrupt controller. From the perspective of ARM architecture, generic interrupt controller will take that interrupt signal from peripheral device, and interrupt controller, generic interrupt controller, will send the signal to ARM processor saying that, oh, interrupt is delivered from peripheral device. But at this point, then control is passed to exception level 1 when there is only one operating system, but under the virtualization environment, some control is transferred to exception level 2 instead of exception level 1. Those kind of operation can be called virtual interrupt. Then what I mean is that the interrupt handling is the first taking place by the hypervisor instead of the guest OS. In particular case, the control is transferred to exception level 3 when you configure the particular system register called secure configuration register at year 3. So those kind of operation is extremely important whenever you think about the primary feature of hypervisor. Let's suppose that there are 3 guest OS in your system, and then some of the peripheral devices can be shared across 2 or 3 guest OS. But in this case, if that peripheral device signal interrupt, there should be another sub stack that will control or the interrupt from the particular peripheral device. That job can be done by the hypervisor. Then right after hypervisor and identify that interrupt, and then right after hypervisor identify that interrupt, then another responsibility of type of hypervisor is propagate that interrupt to appropriate the guest OS. And this kind of the operation can be seen when you take a look at the source code of hypervisor. So let's take a look at the how interrupt exception, IRQ exception, can be taken to the exception level 2 in this case. Let's suppose that the peripheral device trigger interrupt. Then in this case, control is taken to the exception level 2 instead of exception level 1. And then in this case, foreign counter is branched into this exception vector address. This exception vector address can be calculated based on this rule by adding the offset DRX 400 to the exception vector base address. Please remember this rule and how the program counter is branched into the exception vector address is specified in the exception vector table if you refer to the ARM reference manual. So in this video, I just explained about two exception models in the virtualization that is supported by ARM architecture. In summary, if you configure the particular system register, that is hypervisor control register, configuration register, in this case, if the exception occurs at exception level 1, and the control is transferred to exception level 2, where hypervisor is running, then please remember this operation. Thank you for this lecture. See you next time.